All right, so we're going to begin today's session. So today we have Saiduth Ramesh with Team SkillShark, who shall be delivering on the presentation on the following topic: Sim Racing 101 Driving Lines and Data Splines, as a part of the Formula Bharat Academy series. SkillShark is an official education partner of the Formula Bharat 2022 season. So during this webinar, Saiduth will give an insight into how you can learn to set up your vehicle to suit your driver's needs using iRacing and Motec. So without further ado, we'll have Saiduth take the stage. Saiduth, you can go ahead.
Yeah, thank you so much, Kathy, for that kind introduction. So, hi everybody, and welcome to this session on sim racing. I'm really happy to be here today. Very excited to share what I know about this subject. So, before we begin, let me just give a quick introduction about myself. So, my name is Saiduth. I did my mechanical engineering from SRM University from 2014 to 18, and during that time, I was part of Camber Racing. So, I've been part of the NFS team throughout my undergrad. So I was mainly an aerodynamicist. My background was based on aerodynamics. But I also had the chance to drive the car. I did a little bit of business plan work. And in my final year, I had the opportunity to also learn about some management and help in leading the team. So that was what I did in my undergrad. After that, I went on to do my MSc in Motorsports Engineering from Oxford Brookes University from 2018 to 19. And during that time, I was part of the Oxford Brookes Autonomous, the driverless vehicle team. And I worked as a business plan lead during that season. And during that time as well, my thesis was mainly focused on Laptime simulation and race engineering. So I did a project based on track characterization with AVL racing. So this is kind of my forte. This is what I've been, focusing on, race engineering and vehicle setup for quite a while now. So that's just a little bit about me. And right now, I'm working as a motorsport content developer at SkillShark Edutech, and I've also done race engineering for eSports since October. So we took part, not October, actually September. We took part in the GT World Challenge Asia Esports Championship last year. So it was a great experience working with the team, with both the professional drivers in our team to kind of maximize our results. I'll get a little bit into that later on in the session, but for now, let's go ahead and start off with the main part, the basics. So today's session is going to be completely based on sim racing. I'll get you up to speed with what sim racing is, some of the differences between arcade, simcade, simulation, and then we'll move on to iRacing and Motec. So today what we'll cover first is an introduction to sim racing. So I'll tell you what exactly it is if you're not familiar with it. After that, we'll go on to just covering the different platforms, the different sort of simulators, simulation software available in the market. After that, we'll go on to check out the types of equipment that you will need if you want to seriously get into sim racing. Once we cover that, I'll show you the iRacing setup screen. So I'll open up iRacing, I'll show you the software, what you can do with it. We look at an F3 car just because it's quite versatile in terms of its setup. Once that is done, I'll go on to show you how to set up your Motec data channels and what exactly you can do, how to actually make sense of the data that's coming out of the software. And finally, we'll wrap up by just saying a little bit about how you can understand the car better and how you can apply this potentially in Formula Student and in an upcoming competition, which we'll talk about a little later. So on that note, let's go ahead and start off. So the first thing we'll look at, what exactly is sim racing? Well, you're basically trying to simulate your vehicle in a virtual environment. Now, how is this different from a lap time simulator? Well, in a lap time simulator, you have a driver model that's coded into the software, and that is what is automating all the driving tasks that are going on throughout whatever simulation you're doing with whichever specific track. But in sim racing, it's all about the driver putting the effort to control the car. So kind of in a way, it is a driver in the loop simulator. So specifically talking about sim racing, you basically have an interface like this. So this is just a screenshot from iRacing. It could be any other simulator platform, but you have, the UI, the user interface is just very similar to a game, right? You select the car, do your setup work, take it on track, do races. But in the background, a lot of code is actually being run. And it's not just simple code. There's a lot of feedback loops going on, a lot of code that's being done in MATLAB, C++, Python. Most of the software that's generally used in industrial simulators is also kind of used in sim racing software. Now I'll get to the difference between a proper simulator and the sim racing simulators that are used. But in essence, yeah, all of these software do use some sort of a high-tech software in the background. It could even be Python, C++, more rudimentary coding software can also be used. In fact, iRacing is quite an old simulator. So a lot of the data is actually taken from notepad files. And if you're interested in modding and stuff, you can actually maybe check out some stuff which can be done within the rules. Don't change too many things within the notepad editor, because that might seriously corrupt the software. But there are a few tweaks that can be done which are allowed to better enhance your experience in the software. So that's a little bit about sim racing. So of course it's all virtually kept in the environment, but of course you're going to also be giving some inputs. So you have to give some sort of a hardware input, like steering and your throttle, but then obviously you also have things like gear changes and everything else that you can actually do in a real car at this point in time, in this point in the world. More often than not, you can do almost everything that you do in real life virtually in the sim. So essentially, yes, these external hardware pieces of hardware have to be integrated and put into the system, connected to the laptop. Then of course, one great advantage of sim racing software is they're very versatile in terms of shooting out data, which is very important and is extremely exciting. It's interesting, especially from an engineering point of view. So with the right tools in it, you can also extract information like what you can see here. And I'll show you some data channels. I'll show you this interface a little later on when we get to Motec channels. But this is a little bit about what sim racing actually is. So your experience as a driver in the loop, the AI, right? So the AI drivers that are in the software, for example, if you have AI drivers, generally in sim racing, it's more of a multiplayer environment. But even so, there are still some automated tasks, and all of that is essentially software in the loop. So it's all happening inside. There's no external input from your end. So what is the difference between a simulator, simcade, and arcade? I'm not sure. Maybe you may have heard of these terms, but yeah, so these are common terms that you will generally hear, especially if you're into racing games. So a simulator, examples of simulators are things like Assetto Corsa, which is actually the software that you're going to use if you're taking part in Revit this year. Then you have something called R Factor, and then of course iRacing. Now I've only mentioned 3 of them, but there are quite a few other ones that are very popular in the market as well. These are just 3 of them that I took right off the bat, which are quite popular. In fact, Assetto Corsa itself has a variation called Assetto Corsa Competizione, which is specific to GT racing. So it has GT3 and GT4 cars. And that is actually the platform that we used while taking part in GT World Challenge last year. So a simulator is high tech. Okay, it's high end. There's a lot of physics involved. The physics models, the cars used, the cars that are based off real life physics models are about as accurate as you can get within certain limits, and that's why I've put a star over there. The reason why I'm calling them simulators with a star is because it's arguably maybe not considered a simulator to some, and that's simply because it's not as high tech as what you would find in something like a Formula One team's factory, for example. But these are about as close as you can get for people in the market to actually access the type of performance that real cars are giving. Now, Simcade is meant to be a platform that gives you a simulator environment, but is more focused towards enhancing a visual racing feel. It's more fan oriented, right? So Gran Turismo is a very good example of it. Now, I'm not stating that Gran Turismo is purely Simcade. Some aspects are there that could make it a simulator, but more often than not, it's more graphics oriented. It's it's designed to enhance the racing part of it, not just the engineering side of things. Gran Turismo's example, F1 games nowadays, initially it may have started as arcade, but nowadays it's more or less simcade. They've become a lot more advanced. It's more of having a fan feeling like you're a fan journeying through through the eyes of an F1 driver, but still trying to experience as much physics as possible. Then of course you have Forza, the Forza series, Forza Horizon, things like that are a little more arcadey, but Forza Motorsport is a little bit more simulation oriented. So all of these software kind of lie in this category. Then of course you have arcade. Need for Speed, I'm quite sure most of you would know Need for Speed. A lot of us who have been playing racing games since we were small are very familiar with the Need for Speed franchise, but it's more designed to appeal to the raw speed and the excitement of racing. So it's not really not really high, it's not really professional racing per se. Then you have other software like Blur and Burnout, which are a little bit more arcadey in terms of a little bit more fantasy style, where it's a lot of shooting rockets and Mario Kart style performance. But yeah, this is a little bit about the different categories. I'll just get a little bit into detail of the simulators themselves, what the differences between these three pieces of software are. So firstly, Assetto Corsa, it's easily accessible. It's a starter sim, relatively cheaper than the other sims, and it's been there for quite a while. It's quite old. Now I've mentioned accurate tire models. Again, the only reason I mentioned that is because there is one very important data channel that I've noticed that you can get from Assetto Corsa, and I'll get to that when we get to Motec. But the tire models are reasonably good in Assetto Corsa. Mod support, there's a good amount of modding going on. There are a lot of tracks which may not come in the raw game that actually coders and developers design externally, and then there's a big fan following in that sense. And then it's one of the best sims in GT3, and specifically Assetto Corsa Competizione, arguably rated perhaps the best GT sim available in the market. It's even better than iRacing and R Factor. Now R Factor is classic. Okay, it's what you would call the OG sim. It has great physics models. It's one of the oldest sims available. It's a very active mod community. Like if there's a new F1 track coming out, more often than not, if you find a video of someone showing what that new F1 track is going to look like, for example, Miami is planned for next year. I'm pretty sure in a few weeks' time, someone's going to come up with a Miami model. More often than not, those videos are made with R Factor because it's just so versatile. And R Factor is actually the company that designed R Factor, that developed R Factor, is working on some real-time projects as well. A lot of real simulators are also built by the same company or some of the partners that were involved in R Factor. So it's very, very important, very high end, perhaps not the best in terms of what you would want as a personal user, but this is kind of the real deal in the market. And then you have iRacing, robust setup options. That's one reason why I personally like this a lot. A very active professional racing community. So if you're interested in having a professional multiplayer experience, then iRacing is the place to be at. It's more suited, of course. There is a lot of European style racing going on, but a lot of it also has to do with the American motorsports. You have things like oval races, dirt races, IndyCar. The list is endless. There's so many of them. IMSA is a big part of that. iRacing is the place to be if you really want to feel a part of a motorsport community, and it has a good deal of engineering also involved. So we'll get to that a little later. These are major differences between these simulators. Now let's get to equipment. Okay, and the reason I've included this is because, of course, Revit is coming up. So if you're taking part in that championship, I've shown this equipment. Now, one of the rules is that you cannot use a steering wheel. Okay, but I'm mentioning some stuff about steering wheels because it might be useful for you to invest in that as a team or as an individual later on if it's something you're seriously going to take up maybe in the future. Firstly, you can have digital inputs, so that's like a keyboard or a very basic controller that just has keys, buttons, just digital inputs, right? So it's either a 1 or a 0. So for example, if you're going through a corner, you keep tapping you'll have to keep tapping the throttle with the space bar or the up button, tapping the steering. But nobody really wants to drive a car that has full lock or full throttle or full brakes, because honestly, that won't work for sim racing. Your brakes will lock up, your car will oversteer, it'll slide. There are a lot of problems with having digital inputs. So strictly speaking, I think digital is a little bit better for arcade. It's not something you're going to enjoy using in simulation because you're probably going to rage by using that. Well, a better alternative to that is using analog inputs. These are some examples of it. You obviously have a steering wheel, which especially I feel, and I guess most people would agree, the best input you can use for professional sim racing. But using an analog controller like this, like an Xbox controller or a PS4 controller, is just as is really good to start off with. So these analog steering, these joy pads over here, so these little sticks can be used for controlling steering or looking the direction in which you're looking. Suppose you want to kind of turn into a corner and you want to look into the corner, you can do all of that with these inputs. And then the triggers at the back of the controller are also analog triggers, so they work on potentiometers. So it's very easy to, I wouldn't say very easy, but it's quite straightforward to regulate your inputs. Now, the reason why controllers are not very useful when you start advancing in this is because if you go through a section like let's say you're going through a section like Suzuka, where you have multiple turns, right, in the S's, or you're in Silverstone through Maggots and Beckett's, where you have sweeping corners, S's. There's a delay in input. Okay, there's a little bit of latency with controllers, and more importantly, it's just not good enough in reaction time. It's very difficult to really change steering very quickly unless you have very nimble fingers. So that's why it's better to invest in like a wheel and with a throttle pedal set to enhance your experience. So that's about the equipment. So some examples, for analog, you can for analog controller, you can look at Xbox controllers, PlayStation, DualShock 4 controllers, or any other recent analog controller that's in the market. So I haven't checked out some of the other names, but there's still other alternative companies that are making replicas or something slightly different from these. Now for wheels, some of the beginner wheels you can go for is either the Thrustmaster T150 Pro or the Logitech G29. Don't go, I mean, it's better to go for Thrustmaster T150 Pro because that pedal set is a little better than the standard Thrustmaster T150. It also comes with 3 pedals, 3 metallic pedals. So you'll also have the clutch, which is very useful if you're going to look at if you're not going to only look at professional racing series. If you're going to look at something like a Mazda MX-5, for example, you want to use clutches. And there are different drives that control the steering, the force feedback, right, which kind of acts against your steering, just like how you have resistance in real life when you turn a steering wheel. Some of the drives are gear, belt, and direct. Gears are very noisy. They're precise but noisy. They go bad quite quickly. Belt drive is usually the most common one you find. And then direct drive is where you have a direct gear that's mounted to the axis of the steering. And that's probably the most accurate, but also the most expensive. I would personally suggest, if you're starting off, choose one of these two. They are belt drive. I mean, go for a belt drive alternative steering wheel. But that's a little bit about the equipment. I won't get any more into this. So on that note, let's go on to iRacing. So what I will do is open up iRacing, and this might take a bit of time to load. So I'll show you something else while that's happening. The thing with iRacing is you'll need to buy a subscription if you want this. And I believe last time I checked on Steam, it's somewhere around 300 rupees, but that's at the time of this video. So I don't know if anything is going to be changed by then. Okay, so it says it's temporarily under maintenance. So I'll just click test drive for now, simply because it's just a little bit more. I'm not going to show an actual racing thing anyways. So just one second. Okay, unfortunately, this is all out at maintenance for the moment. Let me see if it comes back online by the end of this presentation. I actually want to show you some screenshots. I'll do one thing instead. I have some screenshots of the setup screen. So I'll temporarily just stop sharing my screen. I'll see if I can find those, and then I'll continue with this. Yeah, sorry about that. Luckily, I do have screenshots of the setup screen. So this is typically what an iRacing setup screen will look like. Okay, so when you open it for an F3 car, for example, you have a lot of options here on screen. So you have something like, you start off with things like tires. You can set up tire pressures, change the way in which these, the sort of tire pressures effectively that you want based on the conditions, on the temperature of the track itself. You have other options like aero setup. So for example, here you have things like, changing aero wing angles. Generally for an F3 car, it's based off, I believe the Dallara, is the recent Dallara 317, I think, the one in the game. So that is basically used for the Euro Formula Open Series. So there you have like preset downforce setups. It's not like you can individually change the wings, but you also have preset wing sets that can be added to the car. Because it's a one make series, the teams are not allowed to custom design or kind of change those. So these are some of the options. You change front flap, for example. You can change rear, front and rear ride heights. And then if you go on to the next setup screen, so yeah, you have a lot of other changes you can do. For example, this software actually also shows you things like the sort of aero balance you get when you change different settings. What I'll do is, so yeah, we'll scroll through. And also see here, if you go to the setup screen and you hover over one of these items, one of these options over here, for example, if you click on this, it will actually give you a brief definition of what's actually being done, or what exactly will change if you change one of those options. So this is actually quite useful if for example, you're new to racing or you're new to Formula student, maybe you're just joining the team and you don't know anything about vehicle dynamics, this is kind of a good platform to learn that. It's not necessarily the best thing for learning about cars, right? It's not going to teach you how to design. Actually, nothing's going to teach you how to design. You know, figure it out on your own. But this is not going to tell you, I mean, things like kinematics and those sort of details. All this is going to do is give you a very rough surface level uh, overview of information about what each aspect of the car is. So let me just scroll through this and I'll show you some other parts of the setup. So that is Aero. If we go to this, for example, this shows you changes for the chassis. So this is kind of the treasure for vehicle dynamics. Is you have a lot of changes you can make. You have things like heave springs, standard stuff like heave springs. You can change damping. In this case, you can only change compression and rebound for normal damping. If you're looking at another car like Formula One, for example, or a GT car, you can also change things like fast bump and fast bump and fast rebound as well for all four corners of the car. You see a lot of other options. You have you can change things like your ARB, of course, very very important, especially for fine tuning your performance. And you even have options to change the height of your car by changing stuff like the push rod offset. And that's something really cool about this software. I'm not too sure whether it's available in something like R Factor, but these are the setup screen is so robust. So if you're interested, go ahead and get a subscription in this, because trust me, it's a lot of fun to just play around with this. Very very informative, especially if you like analyzing these sort of things. So that is the chassis. Let's go on to see some other options. So this is a continuation of the chassis. So apart from the main front and rear for heave springs, ride heights, and ARBs, you can also actually change separate options for all the four parts of the car, all four corners of the car. In this case, of course, you have torsion bars, because in this model of the F3, the front springs are basically torsion springs. The rear are normal compression springs, but these are like all the other sort of options you can change. I won't spend too much time on this. If you're interested, just kind of pause the screen here later on and you can have a look at that. And let me just show you some other stuff. So this is the rear end of the car. Right, and then the final option, and very important, especially for top end performance, is tuning your drivetrain. So you have things like gear ratios, the gear ratios you're going to use for each gear, differential setup. That personally for me is one of the most awesome things about this. And trust me, you might think it's just general performance. Diff might not have a huge impact, but if you're going to drive these cars in this game, in this sim, differentials are very 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 important. This will perhaps change your experience more than anything else in the setup screen. At least from my experience, this is what I've understood. But there's a little bit about the setup screen. I'm very sorry I couldn't show this in iRacing itself, but I think coincidentally today it's under maintenance. So on that note, yeah, these are just some screenshots. So with that, let's go ahead and look at Motec. Okay, so this is where you want to actually take a lot of data. This is where you're going to analyze all of your data. So what I'll do is I'll show you how to open up Motec. So what you want to do is go to this link over here. So just type Motec i2. So the software, the data analysis software from Motec is called i2. Preferably download i2 Pro. It's free and it's available. I think, yeah, just choose the 64-bit option. So when you click this, the first thing you get when you open Motec is the screen like this. And what you want to do is create a workspace. Now, a workspace is where all your data analysis work is going to be done. Okay, I already have a few workspaces here, but for now I'll show you how to make one from scratch. Okay, so click create a new workspace, go through this wizard, select circuit if you're doing it for circuit. If you're doing drag, choose drag, but I would suggest just choose circuit either way. It's just more versatile. And this will be useful if you're again taking part in something like that, the drag event in Revit. Ideally, what I would suggest is make one workspace for every single sim platform, But if you're going to be doing analysis for many different types of cars, then I would suggest make one workspace for each car for that sim as well. And the only reason I'm saying that is because if you get really into this and you get a lot of data coming through, you will want to make sure you have a custom workspace for each thing. In fact, you might want a custom workspace for analyzing general data, and then another workspace for analyzing telemetry data if you're doing race engineering for a live race when a driver is actually running a race. So this is your workspace. Okay, now these things here are worksheets. So when you click circuit, it's going to give you standard worksheets like this. The first thing we'll do is we'll import some data. So I've actually done already a few I've done a little drive in Phoenix, in the Phoenix road course with the F3 car. So I'll just open that up and show you the data for that. So one thing you'll learn very quickly if you start getting into this is you're going to get a lot of data, and you're going to have to make sure you put them in the right folders and you have a good structure for it. So in this case, so I've got two laps over here. So these are two that I have that I've generated. Okay, so when you load the data, you'll probably get something like this. Now when you click data over here, you can see all the data that you have loaded. So I have a base setup over here. Okay, with so long back I created a setup for Phoenix, and I'm just running a base lap. Usually it'll select the fastest lap over there. So for example, this is the fastest lap. So I'll keep that for now. I won't select anything from the second lap yet. So all the data you're seeing right now is for the first lap, the first thing that's selected. Now, what you can do is firstly just scroll through all of this. If you're new to the software, scroll through these things and see what is available, what is being shown over here. And this is just give you a quick overview of the different things available. This, for example, is a track report throughout Phoenix of what's happening in each section based on whatever metric you choose. So, for example, here it's just for speed and for engine RPM. Multiple other things, you can set up a lot of reports. Okay, I won't get into the details of that specifically, but this is very important. If you're taking part in the competition, then you need to understand how to analyze what your driver is doing. So these are data channels here for what the driver is doing. Now you can already see that these things are not changing at all, and that is because the standard basic auto-generated workspace that is created in Motec might not actually have the right channel names compared to the sim that you're using. Here, if I click on channels, all these channels here are the channels that the simulation has generated. So these are the channels that are available. These are channels that iRacing has projected, iRacing has given out for the F3 car. Now, the first thing you'll notice, you'll soon notice that when you start trying different sims for the same car will give different types of data. For example, some simulators might give you slip angle for each tire. Some sims won't do that. The sims that do give the slip angle seem quite generous because that is confidential, and that is relatively confidential data. What I've noticed, what I understand is most of these simulators will give out data that is actually being used in its code. Maybe some of the simulators might not have slip angle as part of their code, at least on the front end, and that is why it is generally not given out. Anyways, I'm rambling at this point. Basically, my point is you have a lot of different tabs over here. So just for the sake of this, let's right click over here. I'll make a new workbook. Sorry, yeah, I told these are worksheets. I'm sorry about that. These are called workbooks. Okay, all of these, and these are called worksheets. These tabs are called worksheets. So we'll call this FB presentation example. Okay, and click OK. You have your first worksheet. Now, what you want to do is add some graphs over here. Now, these are all the types of graphs available. You have time distance graphs, which are almost always used. That is basically every graph that you see with all the squiggly lines and the x-axis that it's either time or distance based on your setup. All of those are based on the option. All of those are time distance graphs. Then you have other things, the color graphs, histograms, extremely useful when you're looking at damper velocity histograms. Suspension histogram, again, that's auto-generated from this. Scatter plots, useful for aero balance, G-force as well. Mixture maps for RPM, fuel. FFT, again, I wouldn't say very useful right off the bat, but when you get deep into the analysis of things like suspension elements, then yes, then you can add other stuff here. So let's put a time distance graph. Now, what we'll do in this example is I'll set up a worksheet for analyzing everything about your driver. Okay. So what do you want to do? You want to first add groups. So what a group does is, I'll show you. For example, if you make a group here and add some channels, let's say you want throttle. So it might not be called throttle, it might be called something else, but just first have a look at the channels, try to understand what each channel is for that sim. So here it's called throttle. That's good. Put throttle. Let's add another channel for brake. So let's try adding brake pedal position, brake. Let's go with brake pedal position. And for now, click OK. So now you have a group. Okay, a group, a time distance graph with a group. Now this is stretched out quite a bit. So let's just push it back here so that you have space for other channels. Now, what you see here, so you have 0 to 100. These are both percentages. So it makes sense. It makes sense to obviously have, graphs and data channels with the same unit in the same group. And here you can see that it's all shown in terms of time. Okay. Now generally you don't want to look at it in time, and I'll tell you that when I'll tell you exactly why we're doing that when I bring in the other lap. But for now, you can move this around by dragging here. If you want to zoom, just kind of scroll with your wheel, and if you want to reset everything, hit W on your screen. It comes back to this. Now let's add another group. So right click here, add. Either you can add time distance graph, or you can just add here, right click here and click properties. It's better to just do it in the same time distance graph. Add a group. Let's do one group for steering wheel, steering angle. So see, there are a lot of things here. What you'll need to do is kind of experiment and see which one is working, because some of these are duplicated from the standard channel set that Motec generates. It might not be, but it might not actually be available. If you put the wrong channel, you might not get any data at all. So for example, put steering wheel. Let's add another group. And now let's say you want to understand, I don't know. Let's try putting. But for now, let's leave this. I'll add something else later. Remove this. So if you click OK, you get another graph over here, right? Now you can expand this. If you right click this and add one more group, if you add 3 more groups over here and click OK, nothing shown here because there's no data channel. But for example, if you add a group and add something else like I don't know, front, let's make one for tire pressures. Okay, so you can select multiple channels. So just hit control and then you can just select all the ones that you want. So let's put tire pressure for all 4 tires. Click OK and click OK. And then it inputs it here, and then it gives you the tire distribution. Now what you want to do is deselect this. When you deselect this option over here, it gives you everything in terms of distance. Okay. Now it's not just a time distance graph that you can use. What you really need most of all in any sort of analysis like this is looking at the track map. So hit track over here, track map, and here it's automatically generated. But I think when you first try it with Assetto Corsa, if you do it for Assetto Corsa or even for this software, sometimes it might not generate the track. It's generated here because I've done it in my system before and it's saved. But if it doesn't generate, you have to click generate track. And there are 2 ways in which it can generate. Okay, either it'll take GPS data in the game, for which you'll need GPS for longitude and latitude. In this case, it's not available. Another way to do it is taking lateral G and GPS. So based on the lateral G of the car, for the most smooth lap possible and the speed, it basically generates, it automatically generates and plots out the track. So this is what is used by Motec to do that. It doesn't just kind of trace what the car does, it has to mathematically extract it. And then of course you have to click close, a crossover, open, so that it doesn't get confused. If you have a track like Suzuka which has a crossover, then you'll need to select crossover. Otherwise you'll get some real weird like loopy shape. Here, for example, let's just click closed. Okay, it's generated. Now, if you want to show this track, we can add it over here. So right click, add track position, and you've got this track. Multiple options you can change. I'll leave that to your imagination to kind of edit stuff. Now, if you want to move this around, you just have to drag, select, and then drag it around. Makes sense to put the track position here, for example. It's just out of the way of everything else, but it's still accessible. Then you can add other stuff. Maybe you want to see your throttle and brake position and all of that in terms of a more visual graphic sense. So yeah, you can add something like Yeah, so you have to go to gauge over here and then select bar. And then what you can do once you select that is select the channel. So again, you need to select what channel you want to do. So let's do it for throttle. Okay, then you can change stuff like the display. You want it to be vertical to show the throttle position. Color bands, auto. Click OK, and you have a throttle bar over here. Now you can adjust the size, add another one for brake, and then that'll show you so it'll show you instantaneously what your car is doing in throttle and brake. But what it doesn't do is it doesn't tell you what it's doing over a course of a certain amount of time, which is why it's more of a fancy thing. It can be useful at times, but more often than not, I would say don't use this unless you want your, you just want your dashboard to look fancy, because it doesn't give you a lot of useful data. So now if you drag through here when it gets to the brake, it activates that. So this is just an example of different things that can be done. Now what we'll do is now I'll include the other data. Okay, so I'll include the next track that we have. So click data over here. And now we want to include a track as an overlay. Okay, so the first lap I have over here is just a neutral, is just the fastest lap I could do with the normal setup. The second set of data over here is the lap that I was able to do after changing the front wing. So I changed the front wing. I increased the front wing angle by 2 degrees. So what that did was it biased my aero balance forwards by 0.6%. So it went from 42.2% all the way to 42.8. So now see, if I select this in the first column, it deselects the other one. What I want to do is keep that as the reference, as the base, the reference, and go to this last column. Okay, select that, you get a number 2 over here, which is green. If you select, select another graph over here, it'll be number 3, number 4. You can select as many laps as you want, but for now let's just analyze 2 laps. So now let's close this off. Both laps are loaded, and you can already see it's really confusing. There's a lot of lines over here. So what you want to do is make it uniform so that you can see, a uniform color spectrum, so that one lap is fully in red, another lap is fully in green. So for example, if you want to do that, you have to go up here to single color and click it. And then now it's all uniform. So you can see, specific data plots, and it's just a lot more useful in understanding the whole, the entire track and what's happening between these 2 laps. One thing that'll get confusing is if you have multiple data channels in the same graph, then it gets confusing. Here also you have throttle and brake, and now the throttle and brake for the first thing is all in red. So it's sometimes difficult to decipher. So you need to be careful of what data channels you've put. So this is just basics of what you can do with this. What I'll do is I'll open a setup sheet data channel set that I use. I won't show you all of it. I'll just show you some of the important stuff that I like using. So I have one for iRacing that I specifically use, and it's under custom. I've put a bunch of things that I like looking at. So if I load that same data into this, you'll be able to see it. And this is where I'll just show you one more specific thing that'll be useful. It's just a little tip. And it's probably the only specific tip I'm going to give for if you're using it, if you're doing something in Revit, because I don't want to give away everything. But it's after all a challenge. But I'll show you one thing you can do. So everybody likes looking at the way cars go around a track and whether it's fast or whether you're braking in the right place. But one thing that is extremely important, perhaps the most important data channel in your arsenal, is understanding whether your car is oversteering or understeering. Okay. Now in iRacing, unfortunately, the problem is it doesn't actually generate it. And it doesn't actually generate data which you can use usefully to do it. The only main way you can do that is perhaps take something like your yaw velocity, right? Your yaw rate, and then take the curvature of the track, and perhaps take the speed at which the car is going through that curvature. And that'll tell you the required yaw rate you need to match that, to take the corner perfectly. That'll give you a neutral steer. But even that's quite complicated. There is a way to do it. I won't show you that for this. But if you're using Assetto Corsa, one really good thing is that you have slip angles. So if you have the slip angle for all 4 tires, then it's easy to at least get the understeer gradient. And that's all you really need to understand whether your car is oversteering or not. Now, in a setup like this, where you don't really understand whether there's no raw channel that shows whether your car is understeering or oversteering, what you can do is just look at things like throttle throttle plots, steering inputs. Before we get to that, I'll tell you why we're going to use it in the distance format. If this were in time, right, you might not be able to see it clearly in this graph because the difference in time is very less. But if I go to this point in time, it shows 15.2 seconds, right? What it's showing is what both cars are doing at 15.2 seconds into the lap. Now, the problem is 15.2 seconds into the lap, both cars will perhaps be at different points in the circuit, marginally, but still it's going to be at different points. So it's not a good reference for understanding what your cars are doing at the same specific point of the circuit. And it gets confusing, especially if there are big gaps. If you're trying to analyze something like an LMP1 versus an LMP2 car, then this is going to completely throw you off, because towards the end of the lap, these cars are going to be 2-3 seconds apart based on the circuit you're driving at. So in that case, what you want to do is get this in terms of distance. So now it tells exactly what each car is doing at 751 meters. This is the best reference when you're changing setups for the same car, because it helps you understand what the driver and what the car is doing at the same point for a different setup, for a different handling behavior for the car. Now, how do you tell whether a car is oversteering or not? Look at things like steering inputs, steering angles. For example, if you see here, look at the lateral G's, the way it's changing based off your steering and throttle inputs. More often than not, if you have erratic steering, if you have opposite lock through a corner, that's a good indication that it's oversteering. If you have too much throttle input and also the car, and at the same time if the steering is locking in the opposite direction, it's more of an indicator that it's oversteering. There's so many ways you can look at data to try to understand that. There's another channel which I created. It's just a gyro pitch angle. So what I did is I took the four corners of the car and just tried to show how much the car is either pitching or rolling. So it's a combination of pitch and roll. I've put pitch on the y-axis, roll on the x-axis, and it's entirely done, I mean, using ride height. So if I right click this, go to properties, this basically shows what I'm using in the y and x axis. Now this is actually a math channel that I've created. What a math channel is you can basically take existing data channels, add mathematics to it, do whatever you want, integrate, sine, cos, any mathematical operation you want to use. You can actually manipulate that data to extract new information. This is what you're supposed to do as an engineer. The thing with sim racing is you only get a certain amount of data. It's your responsibility or your job to take that data, convert it, extract extra information out of it with whatever you've got. If you want slip angle from a sim that's not giving it, you can't just send a mail asking for slip angle. Figure out other ways to perhaps calculate it. This is where it's a test of how much you actually understand vehicle dynamics, how much you actually understand a car. So what you can do here is create different math channels, extract information. What I'll do is I will close this and I will show you data from Assetto Corsa. Okay. For example, I'll close Motec entirely and I'll reopen it. And this is the last thing that I'll show you as an example in Motec. I know this is quite vague, but it's just a quick introduction to what you can do with Motec. If you spend a little bit of time with this, you can do a lot more. What I'll do is, okay, just call it a general worksheet, add a graph. Before that, you have to add data. Now I have Assetto Corsa data as well. Yeah, so I've got a lap of the Lotus 98T, which is the car you're going to use. But with the help of a driver who I've worked with, Sai3, he was kind enough to give me a lap of the Lotus 98T, but around Imola. Okay, we just thought Imola is a good idea because the race just happened 2 days back. Anyhow, this is the data for Imola. So it's already loaded. Now what I'll do is I'll just show you, I'll create a time distance graph. Let's just put okay, for now, let's just put steering angle and then another group with throttle. Okay. Fine. Now that is done, what you want to do is find out a way to check whether your car is oversteering or understeering. So for that, you need to actually use a math channel and create that. Okay, so what we'll do is click math channel. Just go to user and we create one. Okay, let's call this US/OS. Now you want to take alpha F minus alpha R, right? And that's going to give you front slip angle minus rear slip angle. That's going to give you the understeer gradient. So what we'll do is click add expression. Go here, type tire slip angle. So perfect for Assetto Corsa data, tire slip angle is available. So let's put FL, right? And then you need to put plus FR. Okay, and we'll put this in brackets. And what we'll do is take the average of this. So alpha F minus alpha R, it's generally used when you have a bicycle model. So let's try, again, this is a very crude way of doing it, not the best way to do it, but with what data you have, this is a good way to figure out whether your car is oversteering or understeering. So take both the slip angles divided by 2, then put that whole expression in as one phrase, because that gives you the average slip angle in the front. Now what we'll do is we'll make sure that we take the absolute of this. And then we do the same thing for the rear. So absolute, and then we take slip angle rear plus slip angle here, right? The reason we're taking absolute is because you just want the magnitude of front and the magnitude of rear. You're not worried about the sign here. So we take both of these, divide by 2. Okay, you have the entire expression. I believe if you want to, yeah. So this is what you have. Now, front minus rear is going to give you understeer gradient, but just for ease of understanding, you want US to be shown as negative. So understeer gradient, if understeer gradient is positive, that means your car is understeering. So let's just take the negative of this entire expression. Take this whole thing, put negative, hit enter. Oh, sorry, hit OK. Okay, so you want to, it's asking for a name. So I'll call this USOS. Unit, for now, let's not put any unit. Click OK. Close. And then what you want to do is add a group here and then add the channel that you created. So now if I type US/OL, I'll get this. And hopefully it generates data for that. Perfect. So now you have an understeer and oversteer plot. It's very small over here, but that's just because of the scale. So for example, if I open properties, right click this, and then edit, I can change the scale. Right now it's auto. So for now, let's just put it from minus 15 to 15. And it's just zoomed in a little better. Now, from this data, you can understand whether the car is oversteering or not just by looking at the data. You don't even have to look at the other data channels. All you have to see is whether the graph is moving up or down. If the graph is moving up instantaneously at that point based off slip angles, the car is understeering. Now, let's just try opening the track map for this. And this will be the last thing I'll show in this. We'll just get back to the presentation and we'll wrap it up. But yeah, use this, especially if you're taking part in Revit, then this is going to be useful for you. It's just one trick that you can use. The rest of it is up to you to figure it out. But I think oversteer and understeer is the most fundamental thing you need in order to actually tackle any competition. Now here again, there's no graph that's been generated, so I'm going to click generate graph. And here, the reason the track is not been generated is because it's using a default data channel. So it's not searching for the right one. So if I just type lat, for example, CG acceleration lat. So this is the actual lateral acceleration of the car, not whatever was written there. So let's select this, click OK. There you go. The track is generated. Now click OK and you have the track present. So now that we have the track, we can try to understand what's actually happening. So for example, what is this one? It's going through. Okay, so let's say we want to analyze it through this first corner over here, which is Tamburello. So let me just move this. Okay, so let's analyze it for Tamburello. What you want to do is double click and then move it somewhere, and then it kind of zooms in. Okay, so let's see what's happening to Tamburello. So you can already see over here the car is starting to understeer, and just based off the steering angle, you'll be able to understand how the driver is actually manipulating the car to straighten it out. These are generally very straightforward when you see a video. For example, if you're doing race engineering for a driver and you see a video, this is very straightforward. But sometimes the driver might say it's understeer and it's not visible that it's understeer. In that case, it's better to check this data just to confirm how much the car is actually struggling. And then based on that, you can do a lot of changes in setup. I'm not going to get through the details of setup because there's just a lot of information on that. But there's just some intro, there's some basic stuff on Motec. I know this has been quite quick, but this is just to kind of get you up to speed, understand what data channels are, what math channels are, and how you need to deselect that and look at it in a distance domain. One last thing I forgot to show you: if you're comparing two tracks, right, and you want to, let's say you want to compare these two laps, and you want to see how much time difference there is, especially if you're in a distance domain, you want to see how far back one car is with respect to another. You need to just click F3, and then that gives you variance. So it gives you, with respect to the reference, how much time is either being gained or lost. And in this case, when it goes up, that means that the green car, which is the second lap here, 1 minute 36, is losing time over here. Very useful, very useful. I would say you have to use this when you're comparing laps, because that tells you how much you're gaining, where you're compromising on your racetrack. And race engineering is all about knowing how to set up your car to compromise in the right places. So this is a little bit about Motec. I will end the Motec stuff here, and we will get back to the presentation. Just a few more slides left, and then we can go through questions. Right. So let's get back. So you can download Motec from that link. Just type Motec i2 Pro, and then it'll take you to Google it, and it'll take you to the link. But you need to start understanding the car. The first thing you need to remember is it's a simulation, but that doesn't necessarily mean it's a mathematical replica. What this means is simulators like iRacing, R Factor, Project Cars. These simulators are developed, and the cars are modeled based off real life cars. So what they do is they get engineers from the actual car. For example, if it's a Ferrari GT3 car, they talk to the engineers of the Ferrari GT3, get some basic data. In fact, they get as much as they can that the team will give them. And then that's not what they show. That's not even what they actually use for mathematically representing the car. They take that, manipulate a little bit, maybe tweak it to make it a little arcadey, just because these games are not 100% sims, and then add it. So the reason I've told this is, don't think that just because it's in your simulation, it's steering when your driver gives 10-degree steering input, that doesn't mean it's actually going to happen in real life. So don't think that it's designed all the way down to the steering rack, or it's not. Even the steering ratios might be completely off. So the point is, it's not entirely numerical or mathematical. Sim racing is, to an extent, actually quite subjective. It's more about understanding your car, less about having a pen and paper and actually writing things down, because you don't have the design data of your car. That's the first thing you need to remember. Next, figure out performance metrics that are used in coding the car. You might not be able to extract the code itself. In some cases, you actually, if you open up the notepad files of certain sims, you might be able to understand something. But try figuring out your own performance metrics. Okay, based on the data channels you get from your car, try to make a qualitative assessment. Try to qualitatively understand what's happening. See, when I look at this data, I'm not going to see, okay, fine, the frequency at which it's changing is this much. I'm not going to look at the yaw performance, what's the variations in the frequency are, and then decide that this car is not performing properly. There's a lot of noise, just like how in real life you have a lot of noise from data. You have the same thing in sims. If the sampling rate is different, the sampling output is also different, then obviously you're going to, if it's a very high sampling rate, you're going to get a lot of frequency changes, because ultimately your whole computer code is still running on ones and zeros, right? So to a point, at some point, it's still either a 1 or a 0. It's still It's a combination of digital signals. So don't take data directly as it is. Learn how to filter data, understand performance metrics, look at your car qualitatively. This is not a lap time simulator. This is just a racing simulator. There is a big difference. Derive and create your own metrics, of course, to gauge performance. That's why I have a lot of other tabs that I haven't shown you in Motec, because there are certain other data channels, math channels that I've created to better help me understand the car a little better. It's very specific and subjective to each race engineer. Especially in sim racing, there's no one way to do something, but that doesn't mean every method that you use is right either. Now, how does this help an FS driver? And this is towards the end of our presentation now. It helps in driver selection. Now, I have worked in teams where this has actually been done with a simulator, not directly for driver selection, but it is one of the steps taken in driver selection. Now, you might think, okay, how is that even relevant? Because you're just sitting in a chair, in a comfy little chair driving, right? You're not actually feeling the G-forces. But this is more about reaction time. See, what it'll do is it'll test your drivers, potential drivers for your car for racing lines, especially in unfortunate circumstances like this, where it's dangerous to step outside. You need to make do with a virtual environment. So, this is actually a good time for all of your FS teams to start looking at simulators, because it's just a virtual way of testing your driver skills without actually having to go to a go-kart track. See, ultimately you have to physically test, but this is a good way to kind of get a preliminary understanding of your drivers. Then reaction times, again, it's all based on lap times, consistency, and it's unlimited. It's not like you have to pay for every round of karting. Here you have a lot of versatility for testing a lot of stuff, which is why sim racing is very useful, because there's no time limit, there's no resource limit. It's just electricity running your system. But yeah, don't get me wrong, you still have to do stuff like go-karting and testing your car physically, because at the end of the day, it's all a physical car that you're going to take to an event. There's a lot of robust data acquisition for the drivers to also learn. Of course, in most FS teams, the drivers are also the engineers that work on the car. So they do have a good understanding of data. So this just helps them not only intuitively drive, but also understand what exactly is happening in terms of values, in terms of quantitative performance for the car. Also, in terms of driver training, and the reason I put robust data acquisition is also to test your driver skills. You don't want a driver that doesn't know anything about cars or vehicle dynamics or calculations. They need to have a certain amount of understanding, because at the end of the day, it's in their hands. Which comes to driver training, again, vehicle dynamics training, they get to learn more as they keep training and driving. Force feedback familiarization. So if you can somehow tweak some of the code in certain open source softwares, you can actually increase the force feedback coming through the wheel. So one thing, okay, it might not be a physical workout, but when you have very high force feedback, it tests your muscle, memory, and the way in which you can react to changes. So again, it strengthens the driver's endurance potential. Mental endurance, coming to endurance, it's also mental endurance. Get your drivers to run 2 or 3 hour endurance races within limits. Don't do it in an unhealthy amount of time, but 1 or 2 hours to start with, just to see how long they can maintain concentration while driving a vehicle. And obviously track training. This depends on whether you have a simulator or you're using a simulation platform like rFactor, where you can actually develop a track. Now, if you have enough data from previous years, you can potentially recreate FS tracks. And there are a lot of people that have done that. If you go to YouTube and search for FS tracks in a simulated environment, there are teams that have actually managed to recreate auto cross tracks from actual events. So if you can do something like that, it's just a little bit more beneficial. Again, it's not anything compared to the real world, but it's still, every little bit helps in terms of preparation. And for FS engineers, how's it useful? Vehicle dynamics training, again, it's a good way to start understanding and familiarizing yourself with the car. FS car development, again, with rFactor mods, if you can very smartly code stuff, there is a potential for you to recreate something maybe 40 or 50% similar to the actual FS car that you're taking to the event. Again, it's useful for driver training also. FS track analysis, again, if you have the right set of skills and the software, the tools, you can potentially recreate tracks. And that's based on real life DAQ data, especially teams who have been running in Formula Bharat for many years. You might have data acquisitions, data from previous years. So you can actually smartly extract that and actually put it into, you can somehow code it into the track, and based on GPS data that you have, you can actually try to replicate that in the sim. Then vehicle concept development, again, via driver in the loop simulation. The drivers can keep driving the car, and if you trust the data, you can actually help in developing the car. Word of advice though, don't just do this and bring it to the design event, because unless you can validate the error between what you've done in your simulation and what you have in real life, you're not going to get any points. If you can't do that, you won't get points. So these are just tips, but this is very straightforward. I'm telling it as though it's very simple. This is probably an entirely different project on its own. If you want something, if you want to do something like this, get an entire set of people solely working on this and make it an R&D project. Maybe over the course of a long time, you can refine the code. Major limiting factors: tire models are not perfect. Okay, that's probably the first problem in any simulation for vehicle dynamics, is you need to make sure you have the right tire models. And in terms of these simulators, tire models are not going to be perfect because it's very, very sensitive data. Pirelli is not going to give all its information to its teams. Michelin is not going to give all its information to its teams. So it's all about understanding how much of an error there is. And the problem is you can't even actually derive that. Maybe the only way you can do it is get a professional driver to drive a car in a sim, and get that same driver to drive an actual drive that actual car on the same track, and then compare notes and data. It's the only way to really only way to really objectively quantify the error. Developing an FS car model, again, it's an extension of that. Not very easy. Not saying it's impossible, but it is difficult. So you need to understand what you're doing while doing that. Developing and obtaining accurate tire models, again, it's just an extension of that. Even if you get the tire model from the sim, you're still not sure how much you need to tweak it. So you have to do a lot of testing work to figure that out. So a few words of advice before I conclude. These are some quotes. Rubbish in, rubbish out. This is something that my mentor and professor, who was my project guide, Sergio Rinland, used to always tell us in Laptime simulation. It's always rubbish in, rubbish out. Your simulation, if you put the wrong data into it, you're going to get wrong data out. Now, I'm not saying that simulators are rubbish, but try to understand what inputs are given in the simulator so that you can actually understand the data coming out. See, you don't have actual information of what data is used to code the F3 car in iRacing. So whatever data is coming out, understand it in terms of qualitative terms. Don't take actual numbers for what it is. If it's something like ride height, compression, you have a certain point in which the entire suspension is bottoming out. All of that is good. That is important within the sim itself. Don't think that is what's actually going to happen in real life. Chances are it's off by a few maybe even a whole centimeter at times. Your simulation is only as good as your code. So make sure you understand your code if you're doing this. Your outputs are only as good as your inputs. Lap sim is mathematical. Simulation is subjective to an extent. Advanced driver in the loop is a transition phase when you actually have a real simulator like an F1 team, properly designed with a lot of hardware inputs. But testing a real car is the summit, right? That's what you want to do. At the end of the day, you want to make sure you can get a real car out there. But in terms of where sim racing lies, this is where it lies. That's why I've mentioned this. And also, there's no singular way to interpret data, but there are certainly wrong methods. So I'm going to leave you to figure that part out. So yeah, on that note, what are you waiting for? To get involved, get some hardware on, and start driving. Get it all integrated, get a sim, get your car on track virtually, and go racing. Yeah, on that note, I'd like to conclude. There are a few people who I'd really like to thank. These are individuals who had a great impact on everything that I've done in race engineering. And this, in terms of the knowledge I've learned of how to analyze cars, these individuals have helped me throughout my master's degree. And of course, IR eSports for providing the platform, for taking part in GT World Challenge, for doing all of these activities, and definitely the Formula Bharat team for making this happen. This Academy series is a good series to be a part of. So on that note, thank you so much for listening. Thank you for your time. I hope we did it in the right amount of time. I hope this was informative. Again, I hope you've learned something new. And if anything, I hope you enjoyed yourselves. On that note, yeah, these are helpful tools and information that you can check out. I would strongly advise you try to check out and buy analysis techniques for race car data acquisition by Jorge Segers. Very, very important. It's probably it's like the Millikan equivalent for data acquisition and race engineering. Facebook groups, again, these are good Facebook groups to check out for data analysis. and analysis tools, Motec, MATLAB and Simulink, because you can actually extract Motec data, CSV files, put it in MATLAB and Simulink, create your own even control codes, put some data science into it, use some data science concepts, which is why, again, you can also use Python for this. MS Excel is always useful, and it's you can probably do most of your tasks with it. It's just severely underused. It's definitely very, very important. So on that note, yeah, these are important tools. Just as a personal note, I have a channel called Astropaddock GT. So I have some videos on that which cover at least the basic vehicle dynamics as an intro series called Vehicle Setup Bootcamp as a playlist. I haven't added much to that, but I'm planning on putting some more Motec tutorials and a few other details of how to do things in iRacing. So if you're interested in that, do consider checking that out. On that note, thank you so much for your time, and I'm open to questions.
Great. Thanks a lot, Saiduth, for that. It was very informative. I enjoyed the presentation, and I know those who tuned in as well did. So we do have 2 questions. I've shared the questions with you. Just let me know if you have trouble seeing them. I believe Shaunak's question came in the last 15 minutes of your presentation.
Okay. Okay, yeah. So the first question by Shaunak, can you also elaborate on how to generate the data, like which sensors and circuits you use, at least in FS? Okay, so that is in terms of real life data acquisition for your FS car. You will need to first understand your ECU, right? Understand how data is being generated from that, and then invest in a good data acquisition hardware, right? It's a data acquisition box that is compatible with your ECU, right? And from there on, it's just about extracting information, integrating both of that, fixing both of them on the car, understanding how data flows from your ECU to your DAQ. I'm sorry, I forgot the name of the data logger that we used to use. If I find it out, I'll let you know. But yeah, have a DAC, of course, and after that you can use other software. See, it's not just Motec that you need to use to analyze stuff. You can, if you're using something like IPG or AVL, if somehow it's integrated, they might have tools that can also analyze data. Physically, the data you're getting from your car, you can also, I think, analyze it with Race Studio. That's another freeware, I believe, that's available. And virtually, yes. See, if you're using a lap sim software, it's good to use whatever software that company provides. So, example, if you use AVL VSM, AVL has another software, a DAC called AVL Drive, which is custom tailored. It's designed for analyzing VSM data. VSM data can also be generated as a MATLAB or a Motec file, but for, I think, the latest version, it only gives it in a compatible format for AVL Drive. So if it's about a lap sim software, make sure you consult with the company you're getting the software from. Physically testing, yes, you need a data logger. I'm sorry, I forgot the second part of your question. Which sensors and circuits? I'm not too familiar with electronics per se. It's not my domain. But in terms of sensors, it depends on what you want to analyze. I think the most basic things you can do, of course, if your DAC has a GPS in it and if it has a gyro within it, then accelerometer, that's good. Otherwise, if you have to invest in one, buy either a gyroscope or buy an accelerometer. And then you need potentiometers for your suspension. I think that is perhaps the most important thing right off the top of my head for understanding your car. But see, the thing is, you don't have to use specific sensors. You just need to be smart with what data you have. Don't think just because you bring a lot of data to the event, you're going to get points. It depends on how you use that data. But long story short, yeah, I would say go for a potentiometer. How to see inner, outer, and middle tire temperature to determine perfect camber for the car in Motec by SkillShark. Yeah, so what you can do is, I'll just show the Motec screen. So if you go to Motec, you can find some channels that have that show things like that. If I go to my tires thing, yeah. So here I have tire for center, but let's say I want to see a tire temperature for all 4 tires. I'll create a new workbook, add a load the data and then add a graph. Right. So let's say let's just do it for front tires. Okay, so if I type temp, so FL front, we'll just do it for front left. If you add all these channels, you can see the way tire temperatures is varying, right? So you see center and inner are quite high, outer is less naturally, especially when you're going on the straights, because your tires are cambered. If you have negative camber, outer tire temperature is low. But to answer your question on, so that is how to see the different temperatures. But in terms of determining perfect camber, don't only look at tire temperatures, also look at how it's affecting the performance of the car, how much turn in you want either at the front or the rear, how much turn in you want in general, and then adjust the front or the rear accordingly. If your car is rolling a lot, if you have a softer set of softer spring setup or a softer anti-roll bar, if your car is going to roll a lot more without losing grip on the inner tire, then you need to understand that your camber is also going to vary a lot. So you need to accordingly, change the base camber of your car. This is more subject. It's more specific to the track you're running on. Less to do with the car in general. So make sure you adjust it based on the track you're running on, especially if it's a longer race. For example, if you're going to do it in the endurance race, then this is something that you have to check out. Yeah, so those are all the questions I had. If you have any others, feel free to ask.
Right. And so for those who are still with us right now, we do have the Revit virtual racing competition or challenge for which we have already opened registrations, and they will be taking place. I mean, it starts from May 8th onwards. The practice servers open from next week. So if you haven't yet registered for it, head on to our website at formulabharat.com/Revit. And we've got an amazing event lined up with cash prizes as well for this season. So again, formulabharat.com/Revit. We end registrations next week on May 2nd. We've got some really cool things lined up for that. So again, I guess that's it from my end. Thank you so much, Saiduth, for your time, for your presentation. Really appreciate it. As usual, you and SkillShark, and for being a part of the Formula Bharat Academy series. It's really cool, and we are really appreciative of that. So
Thank
to
you.
all
Thank
our
you for the opportunity.
Great. Well, yes, you're always welcome. To all our participants who tuned in today, we really appreciate that you've been there with us, and we hope to see you in the future Academy series. If you like what we show, do subscribe to the Formula Bharat YouTube channel, and we hope to see you at the upcoming Academy series as well. So to everyone, have a good evening. Good evening, Saiduth, to you as well.